This is part 3 of the bicycle fork video. In part 2, we did steps 1, 2, and 3. Step 1 was to insert our master geometry file and make sure that only the appropriate planes and layout sketches were visible. That included the fork dropout plane, the frame layout sketch, the fork dropout layout, and the important tube diameter sketch. Step 2 was to add a tilted plane. It's perpendicular to the front plane and passes through the steering axis. Step 3 was to add a plane perpendicular to the front plane and passes through the edge of the top of the crown. These two new planes are perpendicular to each other. Step 4, which this video will focus on, is going to be to create a layout sketch that shows the fork on the front plane. There are many different shapes we can make for our fork. For this one, the fork tapers down as it goes downward with a gentle curve, and that curve includes the shape of the fork end. This version here has a straight fork that just goes straight from the top of the crown to the fork ends without having any kind of a curve or bend to it. But there's still an offset between the steering axis and the location of the dropout slot. This fork is more angular looking and has a very definite bent shape to it, where it bends here, and then these lines are straight going down to the fork end. Here you see the fork end is not part of the overall shape of the blade, but flares back out again from a narrow end of the blade. All of these designs assume that the blade will be made as a boundary, a series of profiles, and will have 4 guide curves. 4 curves will meet the front plane in a diamond shape orientation. So here, 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 and here. And the profiles will have 4 pierces to these 4 guide curves and will have an approximate diamond or oval shape to it. For example, I will highlight the first profile, and we see an oval shape meeting these 4 points that are arranged in a diamond profile. The actual blade profile sketches that will fit best into this diamond pattern of guide curves can be something like an oval, a curvy diamond shape, a lenticular shape just made from 2 arcs that have coincident relations here and here to our diamond corner points, or even a teardrop shape which can fit into a diamond pattern which is asymmetrical. Going back to our fork, we'll take a look at that front layout sketch. And here we see a diamond pattern that's been put into the sketch, and this is where the endpoints of the various boundaries are going to be. The sketch includes a depiction of the top steering tube, a rough depiction of the crown, the curves of the blade, so this would be the leading edge, trailing edge, and the inner and outer edge, and a depiction of the fork end. Right here is where the axle will pass through. The sketch can also be used to locate conveniently some planes that will be used for your profiles, such as here and here. Also included in this sketch is the outer diameter of the tire, which is convenient to know so that we make sure that the top of the blades don't rub on the tire. So here we see the bottom corner of the blade profile, and we've put a little bit of a gap here to guarantee that there's clearance and no rubbing. Now I'm going to rebuild this sketch from scratch so you can see exactly what I did. I've rolled back to step 3, and the only thing visible are the layout sketches that came from the inserted frame geometry. I'm going to start a new sketch on the front plane. Some of the first things I'm going to do is copy this line. That's where my steering axis is. I'm going to just stretch this way down, and I'm going to turn this into a construction line. Then I'm going to copy some of my important tube diameters, such as the steering tube. So converting entities, I'll just copy this, this, and this. And I want to make sure that the top of the crown matches the diameter of the head tube. Zooming in here a little bit, we'll copy this line, and I will draw a box shape. I'll make sure that this line is collinear with this line. And the same here. This can be dragged out. This will be the crown itself. I'm also going to copy the arc of the tire. Then down at the bottom, I'm going to just draw in a circle on the center here. It's going to represent the end of my fork. And I don't necessarily have to match this diameter. What will be important, however, is making it large enough to easily contain the dropout. I'll make this about 25 millimeters. You can do something different if you like. Now that I've done all this, I feel like I have enough information in here to where I can hide my layout sketches from the inserted geometry and just start building up the rest of my fork layout. I'm going to draw a diamond shape. I'm going to use just center lines here. That's just going to remind me that this isn't the actual profile of the diamond that I'm going to be using, but it's sort of a placeholder with the appropriate corners to where the guide curves will be going. We'll make this coincident with this line, the steering axis. This will be coincident with the steering axis. And I'll make sure that this line is perpendicular to the steering axis, which is also parallel to the top of the crown. I like to make these two lines symmetric with these two lines. The only way I can do that is to temporarily make these non-construction lines. Now I can click on this line, and this line, make it symmetric. And I don't need to do it with the other two because the relations are forcing it to be symmetric. We'll also make this point symmetric with this point about the steering axis. Now that I've done that, I can go back to making these construction lines. I want to make the width of the blade about 55 millimeters and the height about 25 millimeters. You notice that I'm dragging my dimensions off angle, not letting them go this way, but making them go in this direction, so I'm measuring the true height of the diamond. Again, your dimensions might be a little different. I want to make sure the bottom of the diamond does not rub on the tire, so I will add a point here on my steering axis, and I will also make it coincident to the arc of the tire. Now I can add a dimension between this point and this point. Again, making sure it's being dragged out at an angle. I want to make that about 6.5 millimeters. Now that I've done that, I'm just going to drag these points for the crown to these center lines. They can really end anywhere, but that's a convenient spot. Now I'm going to draw in the curves that represent the guide curves for the blade. Zooming out, I'm going to start with the leading and trailing edge guide curves. In my case, I'm just going to use simple arcs. You can use splines if you like. I'm going to make this curve coincident to my fork end and also tangent. I'm going to do the same, the trailing edge. Make this coincident and tangent. And I want to make sure that where this comes up to the top, that the curve is parallel with the steering axis. To do that, I'm going to add a center line here and a center line here. Make those parallel to the steering axis. Now that I've done that, I can easily add a tangent relation between here and here and here and here, and that makes my lines go black. Leading edge, trailing edge. Now I need a representation of that outer inner edge. Assuming that the outer and inner edge are going to be on top of each other when viewed from this angle, so we only have to draw that curve once. In this area here, we want that guide curve that represents the outer curve to be straight. So we'll just draw a straight line here. Now I can add an arc going from this point down to the center of my dropout. I will make a tangent to the straight portion and coincident to the center of the dropout. Once again, you are not limited to making your arcs out of these shapes, and you are encouraged to come up with some other shape than what I've shown here on the screen. Now you'll recall that there's going to be a point where the blade has to taper down and become the actual dropout plate. So I'm going to place that detail in this sketch as well. And I want that tapering down to occur perpendicular to the steering axis. Here's our steering axis going through the steering tube. I'm going to make this line perpendicular to this line. Just drag this to here and to here. And I'm going to add a dimension to the center of the dropout. I'm going to make that about 17. You might want to make this more or less depending on the shape of your blade and what works out best. Finally, what I'm going to do is add some additional guides that are going to help us when we make our layout sketch on the tilted right plane. I want these to be going perpendicular to the steering axis, and then hitting these appropriate points. So I'll make this and this perpendicular, this and this perpendicular, and this perpendicular, and I want this line here to be tangent to this arc. This may seem a little odd at first, putting this in, but if we take a look at this tilted so that our steering axis is vertical, we can see now that I'm just dragging this straight across to the steering axis, and this will be a convenient way of aligning the same details in the right tilted view. So this will show us where the bottom of the fork is, the center of the axis, and where we transition from the fork blade to the fork dropout plate. That concludes this video. In the next video, we'll show how to make that tilted right hand view.